Hello everyone, I hope you all are doing great. So in the last tutorial of data structure, we touched on the concepts of array and I feel that you guys are able to perform few operations and are comfortable with the concept of arrays. Moving on to linked list. So what is a linked list? It is a linear data structure where elements are not stored in contiguous memory location. Like arrays. So here elements are not stored in contiguous memory location. So we have it consists of nodes, and each node has two key elements. One is data field, and second is link field. Let's understand this by using some diagram. Okay. So this is my node 1, node 2, and 3. Every node has a data field. So data 1, data 2, and I'm writing data 3. And this next field is link field in every node, which points to the next node in the linked list. So my first node is pointing to the second node, and my second node points to the third node. If a link field points to the null, then that node denotes the last element in the linked list. So I'm going to point the last link to the null. Okay, so each link is linked with its next link using the link, and my last link carries a link to the null. So it marks the end of the list. In linked list, we have various type as well. So the one we discussed just now is simple linked list, as I can traverse from first to the next, next to the further next, and the traversal is forward only. If the last node points to the first node, then it results into circular linked list. So if my last node, instead of pointing to null, I just delete null, and I'm going to create a pointer which joins my last node to the first node in the linked list. Then it becomes my circular linked list. Uh, the other type in linked list is my double linked list. So in that, what happens? Every node has two linked lists. One points to the next node and one points to the previous node. So we can have the navigation in both ways, forward as well as backward direction. So this denotes my double linked list. Similarly, I'll have a link from my node 1 to the last node also. Let's have a hands-on activity. Please try to code along with me. It would be helpful. So I'm going to create a class which will represent my node. So I'm going to define my class as node, and I'm going to create two public variables. One is to hold the data, and one would be my pointer of my node type, and I'm going to mention it as left. So we are done with the class declaration. Then I'm going to create a function to insert elements to the end of the linked list. So I'm going to declare a function, and the function name as insert end of the linked list. So insert end node, which will be taking the parameter of my node type. And for insertion, I need to have a data also. So I am going to create a new node, which I'm going to name as new node itself. Okay, so we have created a new node. Now we have to assign data to it. So new node data is d that I'm getting from my function parameter, and my new node points to null. Okay, this whole functionality we can also cover as part of my constructor also. But for this program, let it be here. And then I'm going to create a temporary node, assigning it to the head points to the first element in the linked list. So if my head itself is null, then what it means? It means this is the first element. So till now my linked list is empty. I don't have any node. So my new node is going to be the first node in the linked list. So I just need to assign my head to the new node, and I'm going to return from this. All right, but if this is not the case, it means I already have a linked list and I want to insert the new node to the end of the linked list. So for that, let's travel the linked list. So here I have declared this temp node, which is the first element in the linked list, and I'm going to traverse all the links till the last node. So while my temp left is not equal to null, I am going to traverse the linked list. So temp will be temp left. Okay. So after reaching the last node, I just need to put temp left to the new node. That's all. Okay, coming to the main function, I'm going to create the root, or you can say the first element in the linked list. So I've created a new node and naming it as root. Then I'm assigning the data. I'm going to put it as 10, and it points to null. So now I want to insert more nodes to the linked list. So I'm going to call the function insert end node, and I will be passing the first element in the linked list, that is root. And I want to assign after 10, I'm going to assign 22. Then one more node, so the first element and the value. So after that, let's check if we are able to create a linked list which is having 3 nodes. So I'm going to use while loop. While my root is not equal to null, let's traverse the linked list. Cout data is just putting it as root data, and my root is root left. So every time I'm moving from first node to second node to third node till that node points to null. So let's run this program. Maybe that's an array. Oh, sorry. This is a void data type, so we should not return any value. Okay, I have just put the wrong operator, so root not equal to null. So data is 10, then 22, then 34. So let me make it more readable. Data is this, then data is 22, so our linked list is 10, then moving to 22, then 34. So my last one is null. Yeah, after 34, that is my end of the linked list. I'm going to provide the GitHub link for this sample code, and you can start from here itself and play around the function of inserting the node after a particular node or inserting the node in the beginning of the linked list. Then you can modify this program to perform the operation related to double linked list or circular linked list. Um, if you want me to cover those topics in depth, please mention in the comment section. And if you have any concerns, don't forget to raise those points. I hope you like this video. Thank you and have a good time.